Greetings and welcome. This is a presentation of procedural notation. We're going to be looking at the quadratic formula, along with introducing condition helpers and multiplication as a function, not just as a sequential hyperoperation. Our main focus is going to be on the quadratic formula. Here's an equation and the formula to go with it that will solve for x. And this is where students encounter the plus minus for the first time and repeatedly forget that everything under the square root symbol must be completed first, and it's not a pleasant experience. There's actually something very interesting visually happening in there, but PEMDAS hides it because we can't see the operations as they're really happening. If we take b to the power of 2, subtract a sum, and bring it back down to the scale of 2, that's what's happening there. It's raising to the same power as it's dropping to the root, but we don't put a 2 on the other side, so your brain does not trigger that matching 2 symbol. Here we can also see multiplication as a sequential hyperoperation, being equivalent to the same as a functional set of operations. So here is for function A, function C. This would be something like the imaginary unit, where we need to combine our polynomials or any multiplication that goes in line. If we simply need to save space or declare a combined unit, this is an appropriate way to represent multiplication as a function. We also have the condition helpers. So this blue line on the left is a helper that applies to the length of the formula that it covers. So for the entire length of this equation, where c equals d, a and b must be true. We have no decoration at the end of this left-hand horizontal line, and that means that this is an and statement. It's the simplest of them. So a and b must apply to both c and d. If I didn't have this blue line and it was connected directly, that would imply that only A must be true for C and only B must be true for D. When we need to convey a sort of parentheses, if you will, for our conditions, we can use a helper line. And helpers can be very helpful. Here I have an equation, some unknown formula with x in it, some other unknown formula with x in it, and E, we shall say, is the equivalent, an equality, to those two equations, but it does not contain x. In this case, we could bind a condition to those two sections, C and D, using what we have in F or G. You'll see this fishtail is the or statement, and so that implies that F or G must be true for both C and D, but it doesn't apply to E. A and B must be true for all three C, D, and E conditions, or C, D, and E equation sections. I don't think you can do this in PEMDAS. And so let's put this all together and take a look at 2x squared minus 3x plus 1 equals 0. That will be the equation we use for this example. And we're going to translate it into procedural notation. That is 2 times x squared minus 3x plus 1. And you'll see the nature of the polynomial is self-evident here. We have a component and a component and a component of the polynomial. And each of these stands out because it's attached to the root of the equation. We are going to fill in our variables. 2 goes into A, negative 3 goes into B, 1 goes into C. And now we can represent the whole thing and even do our work on the side, something that you can't really do in traditional notation in the same convenience, as in each operation allows me to check off a line. Did I get that number? Did I get that number? Yes, I've calculated them all. And when I perform each of these operations under the condition of A equals 2 and B equals negative 3 and C equals 1, then I get the answer the array of x, pardon the programming term, is equal to 1 and a value of 1/2. So we have two answers, and in procedural notation, if we have more than one value, as in we have a list of values, an array or set or group, then we use this little square symbol open to the left. So an open bracket to the left indicates that this is an array. Our entries are 1 and the value of 1/2. And so if we work out our numbers, we can see 3, 9, 8. 9 minus 8 is 1. Square root of 1 is 1. Divided by 4. And that was 3 minus 1 is 2. Divided by 4. And we get 3 plus 1 divided by 4. And we get 1. And we get 1/2. And those are our two answers. So our plus minus still sticks around, but at least our square root symbol and our exponent are now matching, and they look kind of nice. If this was of some interest, if you found this helpful, or would like to know more information, or have some general comments and feedback, I am more than happy to respond to respectful comments, and I hope you all have a nice day, and take care, and I will see you again soon with another lesson. Take care. Bye-bye.